Probably do about 4, and then I'll let you guys start working through them. Jarrett. So, when we start looking at these, it's just a process of going back and forth and just determining what you need to do to balance the equations. So, we're doing 7E. So they'll have solids, they'll have gas, there's some that are diatomic. We'll get into that when you guys have to write them out yourselves. But when you write them out yourself, like oxygen, nitrogen, hydrogen, those are all diatomic, as well as the halogens. The halogens are all diatomic if you write them by themselves. So this would be one where this is a synthesis reaction. So every time I write one out, I'll describe what reaction it is. And by the time that we do enough of these, you'll probably kind of get an idea what the different reactions are. So this is a synthesis. Can you see why it's a synthesis? Well, this S means solids. So that's just a state of matter. You take a solid and a gas, you heat them up together, and then what happens is you make a different combination of copper and oxygen. So this is copper 1 oxide, and this is copper 2 oxide. Okay? And so when you add oxygen to it, then you're causing this one to get rid of an electron and become a +2. So synthesis, you make one product from 2 reactants. That's what a synthesis is. That makes sense? Synthesizing, making one thing. Okay, synthesis. So on this one, again, you don't have to do this on every single one, and we'll do a couple where we don't list them out. So this is Cu, and this is O, and then CuO. So then when we look at it and do the counting, it's 2, and how many oxygens do we have? 3. And then here we got 1, 1. Okay? Now, this is what makes balancing difficult sometimes, is that you might have an element in multiple spots. And when you have elements in multiple spots, you definitely want to balance it out at the very end, when possible. Sometimes it's not possible. Sometimes you gotta attack it right away. So, if you notice, this one's going to be pretty easy to manipulate, the CuO, for the number of oxygens, because you can put any number in front of this, and it just multiplies that by that number. So if you put a 2 there, that's 2. You put a 3 there, that's 3, and so on and so forth. So the left side's what you're probably going to have to focus on. So let's say we balance the copper. And put a 2 in front. And that's a coefficient. So we got 2 and 2. So we got an issue. We got a copper is balanced, but the oxygens don't. So you're going to have to find some way to get those to balance by manipulating the left side. Okay. So what I would do is I would try to manipulate the one that has multiple variables instead of the oxygen, because that one you can just put a number in front of that. So let's just start manipulating it and kind of seeing how we would go. So let's say if I put a 2 in front of this, then that makes how many coppers? 4. And how many oxygens do we have?
4.
We have 4 here, or we have, 2 here and 2 there, that's 4. Is there anything we can do the right side to get 4 of everything?
Yeah, just put a 4.
Just put a 4 there, right? So then we can just go ahead and put a 4 there. So sometimes it's, I tell you what, also, if you get to the point where you're getting really big numbers, then you need to start over. You just kind of got to alright, if you get numbers like 7 and 8, and you're getting up to those big numbers, for the most part, you're going to okay, wait a second, there's got to be some kind of ratio than that. So then, that would give you 4 here as well. Okay? All right. Let's take a look at another with what's polyatomic ions. So let's go ahead and do another one. We're going to look at number. Let me make sure I get the right one here. Let's look at 11D. 11D looks like it's a really tough one to balance. And I'm going to go ahead and put the states of matter, or what form they're in. Okay, so on this one, if you notice, aqueous means it's a mixture of water and these ions floating around. So the aqueous means that these ions are floating around in a solution. And this aqueous means those ions are floating around in solution. And then you put the two solutions together and you get a solid out. Okay, you're going to get a solid out. And then the other solution is aqueous. So this looks like a really tough one to balance, and you got a lot going on here, it looks like. So when you list these out, list them out not individually all the time. So if you look at the OH, you have an OH there and you have an OH on the right side. So what we're going to do is we're going to count those OH ions. So those are polyatomic ions. So we're just going to count the OH ions. And then we're going to do the same with the phosphate, because the phosphate occurs on both sides. So we're just going to count those just like they're a single element. In this case, they're just a polyatomic ion you're counting. So then we just do the other side as well. Okay? So how many do we have of VA? So this 2, remember, only goes with whatever's directly behind. It doesn't go, so it's just, you just have one barium. Okay, how many hydroxides do you have?
2.
2. Sodiums? 3. And phosphates?
4.
1. 4 oxygens, but 1 phosphate.
As part of the name?
What's that?
Does the 4 just count as part of the name?
Right, so if you look on your polyatomic ion sheet, and if there's any questions of if that is a polyatomic ion or not, I think you've dealt with them enough when we were naming. You can look off this sheet and it'll have it. So it'll have that PO4 on here. So you can just double check. Alright, so we're going to make it simpler. So on the right side we got 3, we got 1, 1, 2. So we can start at barium and kind of see where that takes us. So what would we have to do to balance barium?
Times it by 3.
So we put a 3 in front, and that changes this to 3, and it changes your OHs to how many?
6.
6. 3 times 2 is 6. Okay, so let's go to hydroxides next then. So we'll come to the right side, and we got 1 hydroxide. So what we would need to do? Put a 6 here, and that gets us our hydroxides to 6 and our sodiums to 6. So the first 2 are balanced. So we're going along pretty good. Now we do sodium. What do we need to do to balance sodium out?
2.
Okay, so we put a 2 here. That makes it 6, and then this is 2. And we're balanced.
That wasn't actually that hard.
No.
I like that.
In fact, these are probably, the one with polyatomic ions are probably ones that can be even easier because in that process. So, okay, questions you have on that? Okay, we'll just do 2. We'll do 2 more that are a little bit more difficult, and then I'm going to give you time to work on these on your own. Okay? So, let me do one where we've got oxygens in multiple spots. So we're going to go Fe2O3. The one we're copying down is 11A. Plus CO, carbon monoxide. Makes iron and CO2. So you can take iron ore, and this is what they do in the steel industry to make iron. They'll take the iron ore, which is really, really easy to get. They combine it with carbon monoxide in this big furnace. And then what happens is it gives electrons to iron to make it neutral, and then it makes carbon dioxide gas. So it's a process of making iron, and then they take that iron and then make steel or whatever they want to out of it. So we go FeO and C, FeO and C. Okay, so we got 2, and we got 4, we got 1. Everybody see why oxygen's 4? Okay, you just have to make sure that you're not looking just in one spot, that you look at both spots to make sure you got everything covered. And then we got 1, 2, 1. Now, in this scenario, you want to leave oxygen to the very end. Why? It's in 2 locations. You're compounding your problems if you try to balance oxygen out first. If you leave it to last, sometimes it balances itself out. Sometimes it won't do that, and you have to attack it. So which one do you want to balance first?
Iron.
Okay, so we put a 2 in front of this, right?
Yep.
So we got iron balanced. Carbon is balanced. All right, so we want to look at this key. Look at this oxygen. It's got a 2 subscript. So the right side can only be even. You guys agree with that? So the right side, when you look at it, any number I put in front of CO2, I'm going to get an even number of oxygens. So that probably tells you this right side, I need to have an even number. I need to come up with an even number of oxygens. Okay? So I'm not going to put the number there. But if I put a 2 in front of this, that makes an even number, and it balances out your oxygens, right?
Yeah.
But if I put a 2 in front of this, now the oxygens on this side is what? How many? If I put a 2 in front of this?
6.
No.
Wait, no.
If I put a 2 in front of that, there's 5. It's not going to work out, right? Because anything I put in front of this, if I put a 2 in front of that, it's not going to work out. What I'm trying to get to, you just got to think ahead sometimes when you balance these out. Okay, so definitely the balancing out would not be 4. You can't get it to 4. How about 6? You think I can get it to 6? Would it balance?
No.
You don't so if I put a 3 in front of this, how many oxygens I have is 6. Can I put a 3 in front of this? How many oxygens will I get? 6.
Oh,
See how that works?
no, I get it.
See, if I put a 2 there, you know, it looks like it might balance, but it doesn't because the left side will be odd and the right side will be even. So I just go to the next number. I put a 3 there and see if it balances out at 6, and it does. So then, is that everything balanced?
Yep.
Okay. All right.
So could you leave it at that, or would you have to change your carbon too?
Oh, I just didn't change this.
So you should.
Yeah. Well, if I know it's balanced, this allows me to keep track. So if I go, okay, in my head I know it's balanced and I don't have to show this, because I'm not going to look at this, I'm going to look at the balance equation. Okay, last one. Questions? Last one. And you guys have to practice these yourself. It's just like you'll get better at recognizing some relationships when you do it. So this is a combustion reaction, okay? And so this is butane gas. This is like a butane lighter. Okay? And it comes out as a gas and ignites. You have to have oxygen for combustion to happen. You always get out these two products when combustion happens. You get carbon dioxide gas and you get water vapor. Okay? So you get those two things out when you burn something that has hydrocarbons in it. So we'll go CHO and then we'll go CHO. And then we'll count. We got 4, 10, 2. And then we got 1, 2, 3. Now, which element should we wait to the very end to balance?
Oxygen.
Oxygen. So let's balance carbons. Got 4. Here I put a 4 in front. That changes that to 4. And it changes my oxygen to 9. Does that make sense?
Mm-hmm.
Now, we want the right side to be what? See this 2 here? What does the right side need to be in oxygens? Even or odd?
Even.
Has to be even. So we're not there yet. We're hoping we can get there. Okay, so then what I put in front of this here to balance out my hydrogens? 5. Okay, wait a second. When I do that, I got my 10 hydrogens, but then I look at my oxygens, I have 13. You guys see that? Okay, well, that's not going to work because I've got to have an even number. So here's what you do. This is a little trick you use on these. What you're going to do is you're going to double both of these numbers. So then when you double both those numbers, you're going to get an even number of oxygens. So you think, well, that's high numbers. But most of the time on these combustions, that's what you're going to have to do. So I'm going to make the 4, 8. Okay, these are the ones that are most difficult to do, to recognize. Okay, and I'm going to make the 5, 10. Okay, so I'm going to go 8, 10. Now I'm going to look at the other side. So what do I need to do in front of this one? So if I'm keeping track, that would be 8. Hydrogens would be 20. And my oxygens would be 26. Okay? So what do I need to put in front of C4H10?
2.
So I go 2, this becomes 8. And this becomes 20. Okay, so then what do I need to put in front of O2?
13.
13. So that makes this 26. So 2, 13, 18. So the thing is, what you have to do on some of these, you can get away with probably doubling a side when it's odd, when you got 2 numbers, and then the other side you can balance out later. Okay? Alright, so you guys will, most of you guys will like these.
Can we do these problems on our notes here?
These problems are going to be on a worksheet so that so it's not going to be out of the book because you would have to rewrite those, and that's just goofy for me to have you rewrite them because that's half the work or more work than you need to do. I would not do that.